Alright, if you remember back in section 7.4, we talked about vectors, and we used vectors to do translations. We took a pre-image and shifted it. We slid it to get a final image, and we slid it by using a vector. A vector told us how far we were going to slide it and the direction. We call how far we slide it the magnitude, and direction. These are important components of a vector. Okay, a vector has initial point, the opposite end of the arrow where it's starting, and we slide it to the tip of the arrow. That's called the terminal point. Okay, initial point and the terminal point, and we label this vector label kind of a half of an arrow. So our first example, P and Q are the initial and terminal points of vector PQ. Write the component form and magnitude. So in order to find the magnitude, we can use the distance formula or Pythagorean theorem, whichever one you like. And the component form, we use these angled brackets. And we want to basically find how far it's moving in the x direction, how far it's moving in the y direction. So if we plot the point 0, 1, x is 0, y is 1, this is P, Q is at -3, 5, 1, 2, 3, 4, 5, that's the terminal point, so we're going to put an arrow right there. It stops right on the terminal point, it does not go past. Okay, so this is point Q, excuse me. And if I want to know the magnitude, you can use Pythagorean theorem or the distance formula. I like Pythagorean theorem because I can just count that we went 4 this way and we went up 4 that way. So right away I see that's a special right triangle, and I know this is 4 times the square root of 2. So the magnitude of PQ is 4 times the square root of 2, or you could multiply that out. And the what were we asked to find? Right, the component form and the magnitude. So the component form is, we went backwards 4, and we went up 4. Okay, so this is, you could think of that as a -4. You could do this once again, plot -2, -1, and 1, 5. So here's Q, here's P, starts at P, goes to Q. The component form, angled brackets, how far did we go this direction? We went over 3, and we went up 2, 4, 6. So we went 3 in the x direction, 6 in the y. And now I can use the Pythagorean theorem, 3 squared plus 6 squared is going to equal my hypotenuse squared. So I just take the square root of that. 9 plus 36 is 45. 9 goes into 45. Square root of 9 times the square root of 5. Well, the square root of 9, we know that. That's why I picked that one. The magnitude is 3 times the square root of 5. Okay, and those are the 2 answers we're looking for. Example 2. Vector AB describes the velocity of the plane. The scale is in miles per hour. So this represents 100 miles per hour. We want to know how far the plane is going if this is the vector the plane is traveling in. So find the speed of the plane. We want to find its magnitude. If we go over 2, 4, 5, that's actually 500, but we'll change that at the end, and up 100. So we'll think of that as 1. So 5 squared plus 1 squared is 25 plus 1, 26. So the magnitude is the square root of 26. Now we're going to use a calculator. We don't want to just simplify that. We want to, that's approximately 5.2 0.099. So scale is 100. So this is a length of 5.09 with a scale of 100. I have to multiply this by 100, and I get a speed of 509.9 miles per hour. Okay, so I took the scale, because this isn't a length of 1, really, it's 100 times that. This isn't a length of 5, it's 100 times that. So that's our speed. Find the direction of travel relative to east. Well, here is east. I want to know the direction of travel. I want to know what this angle is relative to east. So I can use my ratios here, and this is my opposite side, that's my adjacent side. Opposite and adjacent is tangent. If you memorize that SOHCAHTOA, it helps out. So the tangent of opposite over adjacent, but we're looking for the angle, so we're actually going to be using the inverse tangent. Inverse tangent of 1/5. So I'm going to put 1/5 is 0.2, so the inverse tangent of that is 11.331. So that angle is, so find the direction, it's going 11.31 degrees north of east. Now, in this next problem, which vectors have the same direction? These vectors are both pointed in the same direction. So AB, vector AB and CD have the same direction. Which vectors are equal? Equal just means same magnitude. So which ones are equal? Both AB and CD, as well as, oh, I was going to say these two, but they're not equal, are they? This one is one longer than that one. Which ones are parallel? That means the same direction. Same direction, well, these ones again, right? These ones are parallel, as well as these vectors. Same direction. I guess that's, they can be pointing opposite ways, so they can be opposites. So when we add vectors, adding vectors is actually really easy. This might look complicated, but if we have a vector u and a vector v, basically we add the x components together and our y components. A1 plus the A2, B1 and the B2. We add those parts together. So if we want to add these vectors together, this is going to be something that you'll see on the test, and pay attention now because it'll be very easy. Write it in your notes, whatever you have to do. 5, -1, 3, -4. If I want to add these, I add my x components together and my y components together. So 5 plus 3 is 8. That's how far I'm going in the x direction. And -1 and 4 is 3. That is the sum of those two vectors. So you can apply this by a plane that's flying this many miles per hour is represented by this vector. The wind is represented by this vector. So what happens when we add the wind to the flight of the plane? How fast is the plane then traveling? We can just take the 389, add the 50, we're going to get 439. Nothing is changing in the y, right? The wind is just pushing the plane further this way in the x direction. Okay, and then you could figure out the new speed of the plane by using Pythagorean theorem again. There's your last homework assignment for this chapter. We'll be having the test soon. Make sure you're uh, all caught up with all your quizzes. If you got any questions on this section, bring them to class and let's get them asked.